Do we need to use E of X somewhere?
It's that type of thing. Um, I don't even remember. A to the X. Okay. So you write it as, so A to the X is equal to E ln A to the X.
Yes.
So what did they do? Bring the X to the front? E to the X ln A. So if that's equal to Y, then dy dx would be the derivative of the function. I don't know. E to the X ln A. Ln A, yes. So ln A is just a number. So e to the ln A x. And so the derivative of this whole thing, e to the power of something, would be the same thing, I believe. And then times by the derivative of the function inside the function. Which would be ln A up there.
Oh, yeah. Yeah.
So if we swap those around, no, we don't swap it around. So e to the ln A, that should be 2 the, should that be 2 the X? Ln A, and then you just bring this X back to where it was in the power, and then e to the ln goes back to being that. A to the X ln A, and that's just proving where it comes from. Let's make sure about this. So y equals A to the X, which is the same, which you could write as e to the ln A to the X, which is e to the X ln A, which is e ln A times X. Derivative is e to the X ln A times ln A, because you get rid of the X function inside the function, derivative of that. E to the X, and then they just simplified it back down. Okay, fair enough. Let's hope that's not too important. But in general, that's the derivative, and part of the reason what I could go on. Okay, A to the X becomes A to the X ln A. Okay, let's try these.
Is it going to be now? Do I need to change 2 to the 3x to e to the ln 2 to the 3x, or?
So because we've proven it, we can just use the formula. So e to the 3x, what is the derivative of e to the 3x?
E to the 3x.
Yeah, and the derivative of 3x?
3.
Yeah, so it would be that times 3. And so
Oh,
derivative of the whole thing is, yeah.
and so here, will it then be like 8 to the 3x?
Let's see this one. So I think because of BIDMAS, we can't. How did you get 8?
I did 2 cubed and then 3x. Oh no, should I have done 3 times 2?
Let's see. So a to the kx, that is the same thing. So 2 to the 3x times by k, which is the derivative of that. So that's times by 3. And then times by ln a, and a is the big number 2. So does any part of that simplify? So this, because of BIDMAS, you can't make that any simpler. I think that doesn't simplify. Let me check that one. 2 to the 3x 3 ln 2. Yeah, 2 to the 3x times 3 ln 2. So because of BIDMAS, you can't multiply before you do the index. And because we don't know what x is, we can't. And so that's the simplest form you can leave it in.
Okay.
So the derivative of 2 to the 3x is 2 to the 3x times by 3, the derivative of the power, times by ln of the base, big 2.
Okay.
Okay, let's try b.
Okay. Will we make it easier if we do 3 ln x plus ln 7x?
Hang on, they just threw that in there. Let's do c. Let's do c first.
So should I start off by doing 2 minus 3 to the 7x times 4 to the minus 3x?
Yeah, you could do that.
And then do I now need to try and differentiate that? Or
Expand the brackets.
is that going to be like 80 to the minus 3x?
Mm-hmm.
And then minus 12e to the 4x?
Yep. And then you would differentiate that.
And so will that then become minus 24e to the minus 3x?
Minus 3x.
And minus 36e, oh no, minus 48e, sorry, to the 4x.
4x. They had fractions. I did think that's why. It's because it would have to be this 4 would actually have to be a quarter.
Okay.
So it's like 4 to the minus 1 as well. So expand that to the quarter. What do you get?
Sorry, what do I need to do? Sorry.
So expand the brackets again, but this time it's a quarter. It's not 4.
So will that be a half e?
Let's see, half. Yep.
And then minus 3/4.
Yeah, and so differentiate that.
And so will that then become minus 3/2 e to the minus 3x? And minus 3e to the 4x?
I think so. Minus 3/2 minus 3. Yeah, minus 3/2 minus 3. Let us see. Okay, let's give this ln one a go. It's quite different from the others, has different rules, but yeah, so you said you would start by bringing the powers to the front, and so that would be 3 ln x. And what would you do that?
So y equals 3 ln x plus ln 7x. And then I think, do I then need to do e to the 3 ln x plus e to the ln 7x?
So that would be for more like proving. Any idea what the derivative of 3 ln x is? Or I suppose, any idea what the derivative of ln x is?
1
No, it is 1 over x.
over x. Okay, so does that mean that 3 ln x will be 3 over x?
So that one's going to be 3 over x. There is something else you have to do with this other one. What I would do is ln 7x is the same as ln 7 plus ln x, if I remember correctly. The way you add, yes, logarithms are powers. When you add powers, that's when they're being multiplied. The indices are being multiplied. So then differentiate those two. Wait.
So will it become...
Is that how logarithms work? Yeah, I think it is.
Will that become 1 over 7 plus 1 over x? Or?
Well, this one would be 1 over x. This one is just a number.
Okay.
So is it 3 over x plus 1 over x? So that would be 4 over x. So it just kind of threw us into this thing. Yeah, 4 over x. There we go. So let's see, bring the power to the front. So you make it in terms of ln x. And then this one we had to split them up. Ln 7 plus ln x. So there's some revision there. The other possibility is if you have something like ln 7 over x, that's the same as ln 7 minus ln x. This was ln 7 times x, so it's ln 7 plus ln x. So just watch out for that. So with logarithms, to differentiate them, you have to kind of split them up into just something ln x, because then the derivative of ln x is 1 over x. Okay, any questions about that?
No.
Okay, so and that 4, you can't just bring that up because of indices. The index became negative, but that would have to be 4 to the minus 1, which is still a quarter. All right, that's thrown us into this thing. How do we do this?
Okay. So when they say equation of tangent, does that mean it's going to be y equals mx plus c?
Yep. So find m, find c.
So I need to get m first, don't I? Oh, I need to differentiate it, don't I, to get m?
Yep.
And let's be 2x to the x minus 1.
It doesn't work that way. It would be 2 to the x ln 2.
Oh, actually, we proved that earlier. So will that mean the next one will be 2 minus x ln 2?
Let's see, this would be minus 2 to the minus x ln 2. Because the derivative of minus x is minus 1, so it'd be times minus 1. Okay, what's next?
Do I need to sub in 2 for all the x values?
Mm-hmm.
And so
I'd get an exact one for this.
it would just be 4 ln 2.
Yeah.
And then will the next one then be just like minus a quarter ln 2?
I thought it would be 1. Did you put it in your calculator?
I just put minus 2 to the power of minus 2.
Sounds good then. Let's just check. Minus 2 to the power of minus. So that's a quarter. Okay. Quarter. I thought it might be 2 over 2. Yeah. Quarter ln 2. Okay. What is next?
And so does that mean that will then become, so m is 15 over 4 ln 2?
Yep.
And so now to get c, do I just now do 17 over 4 is equals to 15 over 4 ln 2 times 2 plus c?
Yep.
And I'm guessing I should actually like try and solve this without putting into my calculator here.
Yeah.
So if I do 17 over 4 divided by 2,
Yep.
which will be 17 over 8.
Mm-hmm.
So it's and then do 17 over 8. Is it minus 15 over 4 ln 2?
Yep.
And so that's my c, isn't it?
Yep.
And so is my final y equals mx plus c going to be y equals to 15 over 4 ln 2 x plus 17 over 8 minus 15 over 4 ln 2.
Yep. Over 8 minus 15 over 4 ln 2. That's it. And also they got rid of the denominator, but it's the same thing. Yeah, they just wrote a different way. It's grand. Yeah. Okay. Any questions there?
No.
Yeah, and would be helpful if they said exact, but whatever. Let's see this one. A curve has the equation of this. Show that the equation of the tangent at the point. What's the derivative of e to the 2x?
Will it be 2e to the 2x?
Yeah. How about minus ln x?
Minus 1 over x.
Yeah. And so you would just sub in the x coordinate of 1 into that. That would be m. And then how would you get the y coordinate?
To get the x coordinate, do I just sub in 1 into the equation?
Yeah. And I believe you'd get e squared. This would turn into 0. And so you would have the x coordinate of 1, the y coordinate of e squared, the m of 2e squared minus 1, and you'd sub them all in and get c. I think you're okay for that. Unless you insist. Let's see. I think this one. Let's see. Okay. All right. How about this? Won't take long.
So will this be minus 1e to the minus x?
Yeah.
And so, wait, so when it's 2 ln x cubed, is that the same as 6 ln x?
Yep.
And so will that then become, so that's plus 6 over x?
I think that's it. Minus, yeah, 6 over x, grand. I knew it would take long. Just want to see if this were worth doing. Ln x squared, that's 2 ln x, that's fine. This time they want the equation of the normal. You just find m and do negative reciprocal.
Yeah.
It's alright. So these are like threatening to be difficult, but they don't. 4 to the x, 4 to the minus x. What is the derivative of 4 to the x?
Was that like 4 to the x ln x, something like ln 4 or something like that?
Which one? 4 to the x ln x or 4 to the x ln 4?
4 to the x ln 4.
Yeah. Okay. No. See, you could use your calculator to check your answer, but you can't get the exact value with the calculator. These look weird. Okay, how about this one? I think I get it.
I'm guessing, are they asking me to differentiate it again? Or?
So first they're saying write it in the form of a3 to the kx. And you'd have to say what that is.
Well, that. I'm not sure how to start this one.
So you have to make it like 3 to the power of something. So this first one, turn it into 3 to the power of something. How would you do that?
Would I do 3 cubed? Oh no, 3 squared, sorry, and then 3x.
Yeah. And
3 to the 6x.
Yeah, so that one's 3 to the 6x. That one's 3 to the 6x. Simplify.
Will it just become, will A be 2?
Yeah.
And, yeah, okay, 6.
Yeah, 3 to the 6x. And then hence or otherwise differentiate this. And get this bracket thing.
Okay, so, do I need to expand the brackets first?
Because of binmus, you can't. You have to do the index before you multiply, and we don't know what x is. So that's as simple as that we'll get.
For 3 to the 6x, I can differentiate that, can't I?
Yeah.
Actually, for 2, can I just take that? Can that just go away because it's just 2?
Yeah. You can put that aside for a moment.
So will that then become 3 to the 6x ln 3 or?
3 to the 6x times ln 3. It is times by one more thing.
Times by ln 6 or something.
Times by the derivative of the function inside the function.
So times by 6.
Yep. And so that is 3 to the 6x 6 ln 3, if you want to write it the short way. And then we bring back this 2.
So do I need to use the 2 now?
Yep.
So am I doubling it?
I believe so.
So 3 to the 6x 6 ln 3 plus 3 to the 6x 6 ln 3.
Okay. How do you make it look like there?
You write equals 4 ln 3 3 6x plus 1.
You, if you were absolutely stuck, you would do that. How would I do this? I would have just times it by 2. So I don't have all this stuff going on. So 3 to the 6x, that 6 would become 12. 12 ln 3. Because it's like everything times each other, so only times one of them. 12 ln 3. What is 3 to the power 12? It's going to be huge. So there's some kind of smart way of combining that to get 3 to the 6x plus 1. That would be 3 to the 6x times 3 to the 6x or something, is it? I don't know. What malarkey. So they did that. So that is 2 times 3 to the 6x. Yeah, same thing. Yeah, they kind of just did your thing, truth be told. Hang on. 4, 3. They're just being pretty academic about this. They're just being academic. Yeah, I mean, because the big picture is, so let's say you did it your way and you did 3 to the 6x plus, this kind of plussing thing. If you wanted the gradient, let's say for the x coordinate of 1, you would just replace the x with a 1. You know what I mean?
Yeah.
And so that's what this thing is all about. So they just rearranged it. It's the same thing. We had to prove this derivative thing. I'm not good at proving stuff. I'm not doing this proving thing. You'll learn that proving thing. Unless you insist. This one. The curve with equation has a gradient of 2 at point P. The x coordinate of A. This might be worth doing. Yeah, it's a bit different. All right, let's do B. We better do A first.
So for A, will that turn into... Oh, should I first of all make it so that it's e to the 2x minus 2 ln x plus 4?
Yeah.
And then after, do I do 2e to the 2x minus 2 over x?
Yep.
And is that it? Okay. And so now... so this is a gradient of 2, so does that mean we need to do 2e to the 2a minus 2 over a is equals to 2?
I think you're onto something. Okay.
Do I now need to do minus 2a to the minus 1 or something?
You could. Be the same thing though.
Oh, do I need to do minus 2 and make equals to 0 or something?
Yeah, you could.
Do I need to make some sort of polynomial here?
And how would you do that?
Do I need to say let...
No. They have no fraction.
Do I need to times all the sides by a?
Yep.
And so that will then become 2a e to a minus 2 minus 2a minus 2. And then if I factorise out, do I need to factorise a here or something?
Yep.
Or even, and so that'll become 2e to the 2, oh no, it'll become 2e to the 2a minus 2 brackets a and then minus 2.
Yep. You factorized out a, was it?
Yeah.
Mm-hmm.
Then plus 2 and then divide both sides by 2.
Kind of. So if you plus 2, you get that. What do these two have in common? In the bracket?
2.
Yeah, so you can like fully factorize that.
Oh.
And then
Yeah.
you can divide by 2.
Yeah.
And technically you could... Did I put an A instead of E or something? Yeah, I did. Why do I make these mistakes? E. It's E, isn't it? Yeah. E to the 2A minus 1 equals 1. Yep. And big picture is back here we have a fraction, they don't, so times everything by a to get rid of the fraction. And at the very next step you could have divided everything by 2, but it doesn't matter when you do it. Yeah, bring the a's together, send a number to the other side, and then go about it like that way. Any questions there?
No.
All right, I'm sure Bookie has a good reason to make us write it that way. Let's see this thing. So, this is in the wrong chapter. Previous chapter? Looks like it. No, previous section. That shouldn't be that. Let's see this one. Point P lies in the curve. The x-coordinate of P is 1. Normal. Fine. Okay, this stuff. What do you give yourself?
I'll give my about 3/4.
Yeah, that's all right. That's not as bad as I thought. Chain rule. Chain rule just formalizes what we've been doing this whole time. You must have done chain rule before this or something. It's the derivative of the function inside the function. That's what that's all about.
Okay.
Yeah, basically just differentiate. How do you do that?
So do I need to do do I need to first of all do 3x to the 4 to the power of 5 plus x to the 5?
As though it was your first day of doing A-level maths. So you could use the binomial expansion stuff, and you'd have loads of stuff going on, and then differentiate it. Quicker way, just find the derivative of the whole thing. So imagine it was like u to the power of 5 or x to the power of 5 or something. What would be the...
That'd be like 5, and then 3x to the 4 plus x to the power of 4.
Yep. And then what is the derivative of this bracket?
12x cubed plus 1.
And so you multiply by the derivative of the function inside the function. I hope that's it. 3x to the 4 plus x to the power of 4, and then that's 12x cubed plus 1. 12x cubed plus 1. Yep. I suppose I should show you. So they use a kind of formal way of going about it. So they say let u be equal to the function inside the function, the bracket. So then it becomes u to the 5. The derivative is 5u to the 4. Using chain rule, dy dx is the same as dy du times du dx, which is why you have to multiply by the derivative of the function inside the function. So 5u to the 4 times that, and then you swap the u back for what you originally made it. It's long. You can easily make a mistake, and what I find much easier, one of the few things that is easier to do in your head, just do the derivative of the whole thing and then times by the derivative of the function inside the function. That's what I found to be easier. Okay, let's try this one.
Okay.
Oops. And don't let that fool you. That is the same as that. Means the same thing.
Okay, so am I just doing the same thing we just did just now?
Yep.
So for sine x cubed.
Yep. Is that it?
And now I need to differentiate sine x.
Yep.
Which is cos x.
There you go. 4 times sine x cubed cos x, or using the way they wrote it, 4 sine like that. That's probably how they have the answer. Yep. Grand. And so you don't have to go through all this, let y be equal to this, let u be equal to that. Okay, how about this weird stuff?
So that's 5x squared plus 1 is the same as 5x squared plus 1 to the power of a half.
Yeah.
And so will that differentiate be a half 5x squared plus 1 to the power of minus a half?
Mm-hmm. What else?
I now need to differentiate what's inside the bracket.
Yep.
And so that will then end up becoming 10x, I think.
Yeah. And what do you do with that 10x?
Times it by the differentiation for it.
Yep. At the 0.49.
Oh, do I need to do times 10x by a half?
You could simplify it by doing that, yeah.
And so would it become 5x and then 5x squared plus 1 to the power of minus a half?
Yeah, it's a bit simpler.
Do I now need to sub in 4 into the x value?
Yeah. You sub in 4. Go on, what do you get there?
Shop into my calculator.
Put the bit without the minus a half in. See what we get.
And so that is 1,620.
1,620. That might not be right. Did you, because of bidmas, put the whole thing in with the minus a half?
I got 2.2 recurring.
What is 2.2 recurring? I think that's 2 and 2/9. 2 and 2/9. What is that? 18 and 20 over 9? Same thing. Because of bidmas, you can't multiply these two brackets. Nah, hold on. So that's 16, 81. Put in without the times 20 thing, the 5, 4 thing.
Okay, and so that will be...
No. It's 20 over 9. It's 20 over 9. Yeah, it's 20 over 9. The reason why... Let me just now use my calculator to check. 5x squared plus 1. And we're putting in 4. 20 over 9. Okay. What do I need to say about this? That could have gone wrong. It's just that this is 81 and the square root of 81 is 9 to the minus is 1 over 9 times 20. Okay, so far so good. Yeah, so far so good. Okay, unless you have any questions, how about this? Why are they doing weird stuff? Alright, let's go for it.
So... Do I need to first of all get, so it's y equals?
That's long, man. Let me try something crazy. What is dx dy?
That would be 3y squared plus 1.
Okay, and so what would be dy dx?
Would that be 1 over 3y squared plus 1?
It might be. And then how would you get dy dx at this point?
I'd sub in I sub in 1 for y.
I think so. And you would get 1 over 4? Let's see. 1 over 4. Hey, that was the correct way to do it.
Wow.
Hey, there you go. So none of the... I mean, the other way will work. But, well, you might not be able to get rid of the y completely. You might not be able to factorize completely. Let's see. Exam time. Find the equation of the tangent to the curve. We might as well do one of these.
Okay.
And you don't mind me and my silliness. There you go.
So, yeah. So, is that the answer?
Well, that's m.
So we just need to do, and we need to get y equals mx plus c, don't we?
Yeah.
So does that mean we've now got, so to get y, we sub in 1 into 5 minus 2x cubed. And so, do I sub that into my calculator?
Yep. I think it'd be 27.
Yeah. Yeah, 27. So we now have 27 is equals to minus 54 plus c.
Yep.
And so 27 plus 50. So we've got c is equals to 81. So would our final answer be y equals to minus 54x plus 81? 80, yeah.
There we go. Grand.
Oh.
Sorry?
That was 7 marks.
Sure was. This skipped over a lot, I think. I mean, not really. Like, what's the derivative of this thing? 3 and then bracket 5 minus 2x squared, and then times minus 2. That's all right. Yeah, that's the kind of question you hope for.
Yeah.
So let's see this one. Okay, now they're gonna start combining things together. Yeah, how about this?
So am I doing 3/2 and then 1 plus ln 4x and then minus 3/2?
Yeah. What's next? Hang on, it's not minus. What is 3/2 minus 1?
Oh, half.
Yeah.
And do I then need to now differentiate what's inside the brackets?
Yeah.
Which will be 1/4x.
Let's see. So ln 4x, what's that same as?
4.
Ln 4x, a different way of writing it?
Oh, was it? Is it not 1/4x?
What's a different way of writing ln 4x? Not differentiated.
E to the ln 4x.
That's very different. Ln 4 plus ln x.
Oh, right, yeah.
Differentiate that.
And so that will give 1/4 plus.
Derivative of ln 4, it's just a number.
Oh, will it just be nothing?
Yeah.
So will it just be 1/x?
Yeah. So derivative of ln ax is just 1/x without the a. In general, because they're all just numbers. Like you could put into your calculator ln 4. It's like e to the power 4 or something. Okay, what is next?
So that's a differentiation. Does that mean that to get... So I now need to get the gradient, don't I?
Mm-hmm.
And so that would just be... Also, to get y and get the gradient, I just need to sub in 1/4 e cubed for the differentiation for the x value, and then for the y I need to do sub in 1/4 e cubed for the y equals.
True. That would be if you're trying to find the equation of the tangent or something. For this one, they literally just want the gradient, just the m.
Alright, so just 3/2 and then 1 plus ln 4 1/4 e cubed.
Yeah.
And then to the power of a half times 1/4 e cubed.
Mm-hmm. Let's try simplifying this then.
Okay. So for 1/4 e cubed, does that flip it to be 4/4 just 4 e cubed?
I believe it would be. Why do you make me think? Let's see. It would be keep, change, flip. So 1/4 is definitely 4. 1/e cubed. Does that become 4e to the minus 3? I think it becomes 4e to the minus 3. Or we could leave it as 4/e cubed. Let's leave it like that. Yeah. Okay. How about the bracket?
Will that then be... Do I need to times the entire bracket? But I can't times the bracket by 3/2. Or...
No, not before you Do power of a half.
Can I do 3 over 2 times 1 to the power of a half?
What I would do is, so you've got 3 over 2 times this bracket times by this at the end.
Yeah.
So I would do the 3 over 2, combine that with the thing at the end.
Oh, yeah. And then that'll become 12. Oh, no, just 6 over e cubed.
Yeah. So 6 over e cubed, and then let's deal with this bracket.
Will it so for ln 4, do I need to change that into, that'll just be a number?
Sure. 4 times a quarter.
1.
So that's like ln that. Any idea what you can do there?
Sorry, how did you get ln e cubed?
4 times a quarter is 1. So it's ln 4 times.
Yeah, okay. And does ln e cubed, is that just 3 ln e?
Yeah, what is ln e?
Ln e is 1, so it's just 3.
Yeah.
Oh, so the bracket will just be 4.
So the bracket is just 4.
Do I now need to do, now it'll just be 12 over e cubed.
Well done. Wow, 12 over e cubed. I didn't see it. 12e to the minus 3. Did I? Oh, it's the same thing. 12 over e cubed, 12e to the minus 3. Yeah, exact same thing. Great. Whew. I didn't think that would get that simple. I was like, what's the point of all of this? But yeah, that's a bit simpler. Any questions about that?
No.
Just long and arduous. Let me see what these look like. Okay. Let's see. So, I mean, that's more just about like writing it in a certain form. It's less about the differentiation. A curve has equation this. Find the equation of the normal. So that's very similar to what we did. Very easy. This one. What would be the derivative of this thing? How would you do that?
Would I have to start off by doing 3 times 6 minus x to the minus 3?
Yeah. And so derivative of that?
Which will then become minus 9, and then 6 minus x squared.
Not squared.
Minus 4, sorry, minus 4.
Yeah. Is that the derivative?
And then I need to do times by minus 1 at the end.
Yep. And can you simplify that?
Which will then become 9, 6 minus x to the minus 4.
Yeah. And so that last step isn't totally necessary, because if they want the gradient when the x is 4, it would just be, if you put in minus 9 times 6 minus 4 to the power of minus 4 times minus 1, you'll get the same thing. But that's the difficult bit there. Then you just sub in 4, get m, sub in 4 into the original, get y, get c. Let's see these ones. Show the equation of the tangent, so there's a lot going on. Let's just get derivative f dash of x. And what's another way of writing f of x? To make it easier to differentiate.
With 3 sine squared x minus 2 cos squared x.
So I would write it as 3.
And then, yeah, bracket sine x and then squared.
Okay. And so derivative.
So that should be 6 and then sine x and then cos x.
Mm-hmm.
And then minus 4 and then cos x and then minus sine x.
And so that's times minus sine x.
Yeah.
What is minus 4 times cos x times minus sine x?
Will it just be plus 4 cos x sine x?
Can you simplify even further?
And it will become 10 sine x cos x.
That's great. 10 sine x cos x. The x coordinate is minus 5 pi over 12. So you sub in minus 5 pi over 12 and you just keep it in exact form. That's another sine one. And I'm pushing my luck. What is the derivative of sine 4x?
Cos 4x.
It is cos 4x. Don't forget the derivative.
Times 4.
Yeah, and just watch out for that. Okay, I've pushed my luck. 4 cos. We got most of it. Yeah, we got it. Let's see. So there's some exponential stuff. Okay, chain rule.
I think I'll probably give it 2.
Yeah, great. So we got it. So after this is product rule. Yeah, that's the derivative of two things that are multiplied by each other. Yeah, how was that for you, Andrey?
That was good, thank you.
Do we continue this next time?
Yes, please, yeah.
Okay. Any crazy stuff going on in your school with this lockdown?
We're back tomorrow. I don't know. I think it's just going to be sort of back to normal, hopefully. So, yeah.
All right. Any questions for me in general?
No, I don't think so.
All right. Well, well done, Andrey. You did great. I look forward to chatting again next time.
Okay, thank you. See you on Friday.
All right. Take care. Goodbye.